Hi, in this video, finally, we test our linked list data structure. So first of all, let's create a linked list. We just have to instantiate it like this. And I would like to insert, for example, at the start. So insert start, and I would like to insert 12. Oh, sorry for that. Okay. Then I would like to insert another item, for example, 122. Then I would like to insert, for example, 3. And I would like to insert, for example, 31. Okay, I would like to insert the 31 at the end of the list. So, okay, we insert it at the beginning. Then we insert this the beginning, so it's going to be the head. Then it's going to be the head, and we insert the 31 to be the end of the list. So whenever we call the traverse list, it's going to yield 3, 122, 12, and 31. Okay, so let's save it and let's run our application. 3, 122, 12, and 31. What about the size? I would like to print, I would like to print out the linked list dot size, for example. I think it's going to work just fine. Of course, we should get 4. Okay, we have some error because object is not callable. Sorry for that. We have the size, return self.size. Okay, and the problem is going to be that I think we are not able to give the name size because this is a built-in name. So let's give the name size1. If we use size1, it's going to be fine. So let's see whether it's working fine or not. Yeah, it's working fine. So what's the conclusion? That don't use built-in method names. This size is a method in Python. Don't try to override it. Okay, sorry for that. So size1 is going to be just fine, and as you can see, it's working correctly because 4 is the size of the list. Let's try to remove some items. So I would like to remove, for example, the 31. Basically, I would like to remove all of these values. So I'm going to have the linked list that remove. I would like to remove, for example, 31. Then I would like to remove 12. Then I would like to remove 122, and I would like to remove 3 at the end. Then I would like to call again the linked list dot, sorry for that, print the linked list dot size1, and it should yield 0. So again, I'm going to save it. Let's run our application. Okay, as you can see, we have managed to get rid of all the items after removing the items, and as you can see, this remove is working fine. We remove 31, so the last item. Then we remove 12, which is the first item. No, sorry for it, 12 is the last item again. Let's try to remove the first item, which is the 3 in this case. So let's try to remove 3 and, for example, 12 at the end, or not 12, 31 at the end. Let's see whether it's working fine to remove the first item instead of the last item. Okay, and it's working fine. At the end, as you can see, the size of the list is 0. So basically, this is how we implement a linked list. And the conclusion is that why we like linked list, basically for this. Inserting at the beginning of the list is very fast. We can do it in order 1 constant time complexity. Okay, this is how we remove. What's very important, that inserting at the end, we can do it, but it's not going to be very efficient because we have to scan through the whole linked list, iterate through it, have to consider every single item in that list, so it's going to yield order 1 linear time complexity. Thanks for watching.